Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
I'm Dimitri.
We have Mike here. Mike, you're here second time. It's our honor. Can you tell us about yourself a bit? What changed with you for the last couple of months and what's new with BitGlass?
So myself, I'm the VP of products here at BitGlass. I've been with the company approaching actually 7 years now next month. So I've seen the entire ride of CASB and SASE and all this build out. But what's been going on since the last podcast, I think, is this huge amount of draw of the SASE type platforms from a perspective of just, people working from home and needing this remote access that we're going to talk about today.
Let's start with the first question. What's the name of the offering or the product by BitGlass that provides remote access?
Yeah, so our ZTNA solution that runs on top of the BitGlass platform, it's a cloud platform. It's called BitGlass Private Access.
Last time we spoke about architecture for outbound browsing. This time we want to talk about remote access. Is this similar architecture? Can you describe the architecture, how it's working?
Yeah, I can do that for sure. Let me show a slide or two on this. So if you have a look at kind of the problem in general, I think people are trying to solve this remote access problem in many different ways. And there's a lot of different cobbling of solutions together, right? And so you have things like internal applications that people need to access, which is the focus of this discussion today. You have managed applications and web apps and whatnot, which was kind of our discussion last time around SASE and whatnot for the Googles and Office 365s of the world, as well as just browsing in general. And when people try to kind of cobble a bunch of technologies together, it becomes very difficult solution-wise to be able to actually have something that works and is feasible. And so platform-wise, what BitGlass has done is basically combine a different types of technology together that fit under that SASE portfolio of things like CASB, things like secure web gateway, things like zero trust network access and remote browser isolation and stuff like that. And so the focus that we're going to do today is more about this zero trust network access. But BitGlass is essentially a cloud-based platform that's hosted in the cloud, in the public cloud, and allows us to scale globally around the world with points of presence and whatnot. And we're going to get into where those are at and how we provide that service in a moment. But if we focus directly on this ZTNA or remote access solution, what's going on here is people have cloud apps they want to protect. They may have been doing that for a while with platforms like CASBs and whatnot. And now they have a problem where they want access to internal applications. And so those applications could be ones that might be running in their own data centers. That's actually one of the most common ones. Web applications come up quite a bit for things like HTTP and HTTPS. And there are other things you might need to do as well from a DevOps or DevSecOps perspective, SSH or RDP into machines and things like that. But you don't necessarily want to expose those to the internet. Okay. And so that's where this zero trust network access comes in. Essentially what's going on is we have what we call a connector here that sits at the network where those apps are located, apps or services, and it reaches out. So you see the arrows here where it's reaching out to the BitGlass cloud. That's that global disparate cloud deployed all over the world. And what basically happens is BitGlass acts as a broker to be able to facilitate connections from both managed and unmanaged devices for those apps or services. So you're not exposing them to the internet because of the deployed connector on the network that's reaching outward, right? Which is good. But interestingly enough, we have actually been doing this for quite a while, a number of years before this whole ZTNA Zero Trust initiative has happened, but it's only accelerated more recently with everyone working from home and whatnot. So there is actually another option as well that is basically a reverse proxy sitting in front of an application when it is exposed to the internet, where we can tie in, and typically that's done by ACLs and blocking access that don't come from BitGlass data planes. The advantage of that type of approach is that you can actually have a user go to a URL, a known URL, and then have it redirect and push the traffic through BitGlass, as opposed to one that is more of going to BitGlass and visiting that site, right? Because it's not exposed to the internet and doesn't have a DNS access. But essentially, what we're doing here is connecting on-premise or on-network, be it a data center that's in someone's headquarters or wherever, or even actually cloud services as well. So something deployed in AWS or whatnot can also be connected to this Zero Trust Network Access solution.
Mike, it does mean that all my traffic that going to my office or data center going through BitGlass Cloud?
No. So what it means is that, so it's an alternative to VPN. That's the way that most people think of Zero Trust Network Access. Essentially what's happening is before you couldn't get to, in this particular diagram, Confluence, let's say, right? You couldn't get onto Confluence, you couldn't access it unless you were on the corporate network. So what people would do is they'd use these VPN concentrators and you turn on your VPN and then you get access and you go to the Confluence URL, right? The problem with that is that when people do that, they're exposing the entire network basically to that endpoint. And so this Zero Trust Network Access solution, or the BitGlass Private Access, as we call it, is basically a surgical way of just allowing that one particular access to that Confluence server based on a policy and whatnot, as opposed to exposing the entire network.
Do I need to go through your cloud, I'm guessing?
With the private access solution that is basically the focus of this diagram here, what's going on is you have to be connected to the cloud in some way. And there's two ways of doing that. On a managed device, you might have an agent configured so that you can go to a particular service, or if it's not a web app, you might be able to use a thick client, like maybe I want to do SSH from a terminal or RDP from my RDP client, whatnot. If you're on an unmanaged device, though, we can still provide access, and that's by means of you actually going to a login to what looks like an app launcher or a user portal, which I was actually planning on showing in a little bit, and clicking on a link. And so what that'll do is that it will initiate a connection to this Confluence server over the tunnel that's been established outward from the network. So that way you're logged in, you're connected, you access the application, be it on a managed or unmanaged device, and then BitGlass is in the middle there providing security, actually even after the connection as well.
So Mike, I would like to understand the architecture of this solution. As a customer, as a user of the solution, what would I need to do? I need to install a client or on my computer or on my mobile device, or I can use my browser to go and click a link to initiate a connection to the BitGlass Cloud, right?
So you can do both. So you can install the client if you wanted to. And with the client, basically what that means is that you're basically logged in and connected, and you can just go to that internal site and it'll automatically be routed through the BitGlass Cloud to the Confluence server in the example we were talking about a minute ago.
Right.
For the unmanaged device, like for example, a contractor that you may be working with where you can't install an agent, or maybe a personal device where someone might need access, what they then do is they would go to the BitGlass Cloud, they would log in, and then they would go and click on the tile that takes them to the Confluence application.
So my next question actually about something you mentioned, which is in the DevOps space, right? We might have a SSH server at one of these boxes in the internal network of the organization, right. Or it might be an RDP server or my Active Directory domain controller, etc. There is a component that we can see that has to be installed inside the perimeter of the network. Mm-hmm. Can you give us some more details about what is this component? Is it an appliance? Is it the software? I need to install it on every single server, or it's one server that runs and takes care of all of the network? What kind of rules I need to provision it? What kind of access I need to give to this specific unit?
So essentially, it's an appliance that's a virtual appliance. So you deploy it. Typically, people would deploy it in VMware or like an AMI, for example, in AWS. But you deploy it, and it's a piece of software, and you give it resources and whatnot, and you need to make sure that it can connect to a DNS server to basically resolve the internal sites or services or IP addresses reachability-wise that you'd want to RDP to or SSH to in that example that you talked about a second ago. And then you would probably want more than one of them from a redundancy perspective. So you can have multiple of them, and we basically multiplex the traffic across the tunnels that are established out to our cloud. So connectivity-wise, basically it has to be able to reach from inside to outside over 443 to the BitGlass Cloud. And then internally, from a firewall perspective, it would need to be able to look up and reach the things that you are exposing inside the network so that we can resolve them and route traffic to them from the clients that are connecting.
Makes sense. So it brings me to this question of when I'm entering an SSH command on this terminal, and whether it's client or clientless, what happens in such case? How this command reaches the Linux server and executes there?
So essentially what's happening is it's tunneling the traffic through our cloud through the session that's established between the endpoint, in this particular example would be iTerm or some other terminal that you're using, to the actual machine that you've SSH'd to. So once you SSH to that machine, you have this connection, it's established over SSL, it's going through the BitGlass cloud from a tunneling perspective, and you're directly communicating with that server. So you can enter commands and whatnot, and you're going back and forth from a command prompt perspective, CLI-wise, with whatever you're going to do. So you ls and you see the files that are in that folder, for example.
Do you have ability to analyze the commands that I'm entering?
So that's actually a good question. So there is primarily routability and connection establishment with respect to things like SSH and RDP and things like that for services that are non-web-based. We can also actually, with web-based HTTP or HTTPS, do actual inspection there. So you're getting logging and visibility and access control, things like determining the machine is a managed machine. We have some NAC-like device profiling type capabilities for that to allow you to get that access, that SSH access, which is a powerful access, right? Are you an administrator and things like that policy-wise before that session is established. Additionally, if it's not like an RDP or an SSH type protocol, and it's a web app, then we can do actual inspection of the content as it moves back and forth. So if you think about someone maybe logging on from this non-corporate device here down at the bottom, and they're trying to upload a file, if that file contains malware, we're able to actually look at that and inspect it and block it. Or if they try to exfiltrate a whole bunch of sensitive information and download it to the personal machine, we can inspect that as well. So it's not just, like typically people think of ZTNA as a network VPN replacement. And a lot of times they're not thinking about the inspection question you just asked. They're not thinking about, well, what about the threats? What about the exfiltration risks here? And so it's really an added benefit that you're able to look at that and do that inspection and that analysis, which typically isn't offered by things like VPNs or other ZTNA solutions actually on the market today.
So it sounds to me like all the great things that we learned about your product in season 1 are actually applied to the backlink that goes inside the organization now.
One way of thinking about it, that's a good summarization, is it's like the reverse of what the CASB is doing. So what the CASB is doing is connecting from the endpoint to a SaaS app, right? In this particular scenario, you're connecting from the endpoint, but you're connecting and providing security, that same type of security, but for an internal application instead. So yeah, it's basically an extension of the platform. It's pretty natural for us actually as we built it out.
From license perspective, do you still license by users or is it a different license model?
We do. From a user perspective, we license by users. I think that's the most common way that people like to think about purchasing kind of SaaS-based solutions today. And BitGlass being a SaaS service, we've stuck with the model of user count.
From connection to identity, we spoke a bit about this when we spoke about outbound. Here is even more important. When you connect to an application remotely, you want to make sure that you have the right user and you can talk with single sign-on and MFA. Can you describe your integration?
So from an integration perspective, with respect to identity, what we're basically doing there is the same thing we do also in that SASE platform that we have. So we're connected through typically SAML 2.0 to whatever identity provider that might be, the Oktas and the Ping Federates and whatnot of the world. Interestingly, though, I think I pointed this out the last season as well, we have an integrated IDaaS solution as well. So people actually use BitGlass as an identity as a service from a consolidation perspective, kind of bringing everything into one platform. We can connect to a directory services, for example, on the premises, like an Active Directory, where you might be doing, password rotation and other types of things and group creation and stuff like that as well. But we can provide that service for applications, be it internal or ones that are
So in this
apps.
case, if I connecting to a remote application and I'm using, let's say, Okta, for example, or using your solution, when I connect to the next application, do I need to log in again, or it will remember the single sign-on?
No, the connection is actually persistent at that point. You've established a connection to BitGlass. It remains persistent there. It's not like you have to relog in again. So say I'm doing some activity associated with Office 365 that's connected with the CASB components. and then they decide they need to go to that Confluence example I said a minute ago, which is an on-premise server, you don't have to relog in again. It just automatically connects to that, even though it's internal to the customer's network.
I know several companies still create rules by source.
Mm-hmm.
So if I use BitGlass remote access, would I going to have the same IP all the time, external, or is it going to be very?
Yeah, we can propagate that IP address if you like internally with things like X4 and whatnot. If you want to log that in an internal infrastructure that might be looking at that in like a firewall that's sitting in between the BitGlass on-premise connector and the Confluence app or the SSH server or whatnot. But the origination of the connection from a establishment, remember, is from inside the network to outside. So you would see a source, though, of the connections over that tunnel coming from the BitGlass cloud.
So we know that today many people actually experiencing their work and their internet browsing through a browser, right? I mean, so we'll be working, all of the applications are web applications. And I would like to understand better, in this portal that you mentioned, where you can log in, right? And then you'll have different links and icons. What kind of capabilities it has? Let's say I need to deploy a patch on the server and I need either RDP or SSH access. Would I be able to use that solution as well?
Yes, I think the best way to understand this is to probably look at what this looks like. So if you have a look at the screen here, what's going on is we've set up the typical stuff you see from GASBs and the stuff we talked about last season with the web browsing policies and whatnot in the SASE platform. But then down here at the bottom, we've created this private access configuration. And so what's going on here is you see the same types of policy rules that are applied to other applications. But what I've done here is I've configured 3 different things. So inside of this ZTNA application, I've set up a server for SSH, a server for RDP, and another server for HTTPS type traffic from a connectivity perspective. Location-wise, this is the data center where that connectors are deployed, and here are the ports that are in use. So if we go look at one of these things, you're basically defining the host names or a wildcard to a set of host names and whatnot that you might want to expose. Selecting the service, we talked about the most common ones being HTTP and HTTPS, but there's SSH and Telnet and FTP and other things that are predefined. Or you can use an other for kind of an other type of any port type solution. So you're defining here what the things you are that you want to expose, okay? And from a policy grouping perspective, then we have the policies that I was talking about kind of a moment ago before I showed this around matching things like groups. So if you have particular people that are administrators that or DevOps engineers that need access to do that patch that you were talking about, you might put them in a group and allow them access. In this particular example, if they're coming from the same place on the same network where that service is already stored, maybe I'm going to send them direct because we don't necessarily need to hairpin back up to the cloud and back down, right? That doesn't make too much sense. If they're coming from, for example, a managed device by detection agentlessly, that it had to have a client certificate, for example, or maybe with the agent, identifying and profiling that it's coming from a managed Mac or a managed Windows machine, then I might want to just secure the access, let them have access, but not necessarily do any DLP, versus the last rule here, which is more of one of those remote access type examples from an unmanaged device. So here, because they're not on the network, they're not coming from a managed device, they want to actually do inspection of what's going on. So here what we're going to do is we're going to look at what they download and block things like the exfiltration, maybe make them do a justification if they do that. We might want to look at sensitive data. We might want to look at malware because it's an unmanaged machine and block that. So there's different actions you can apply, things like encryption and all the same types of stuff that you saw from the typical type solution, except now exposed to one of these internal applications. So the policy rules are identical here, and these can come from Active Directory and whatnot, or scheme integrations with Okta or whatever.
Is this the same client for outbound browsing and for remote access?
Yes. Yeah. So it's the same client, but it's also that agent-less example. So in this particular example that I have here, I've set up this policy. I'm on my unmanaged device here, on my personal device, and I try to access this application. What you would do is you'd log into BitGlass, and then you would land on something called the user portal. over here. And so you see my SaaS apps over here, but then you also see these other apps down here that we've put this icon on that's around SSH and whatnot. And so say I need access to this Jenkins server that's doing builds over here in your particular example. You can just click on the tile, and what it's basically going to do is initiate this reverse proxy connection. You see the URL rewritten and whatnot like you would normally see. Actually, like you saw in these slides over here that are coming from Google, same type of thing, but it's a SaaS app. What's then going on is you can log in the Jenkins server and do your changes and whatnot. So everything in one platform, all unified there. And then the same thing is true for the agent, the Smart Edge agent that we were talking about in the prior podcast.
From perspective of ports, I know there are several issues with the remote access in general that not all the ports and protocols supported. So printing, for example, VoIP, file share, password changes. Can you describe what solutions support and maybe what's on the horizon?
Yeah, so what we see in the market today is typically, I don't know, maybe like 60 to 70% of things being web services that people are accessing, the HTTP and HTTPS. The next most common things tend to be SSH and RDP, maybe followed by things like maybe FTP or Telnet or VNC or things like that. But like I was showing a second ago in the admin portal, you can really choose any protocol you want there. So the difference though being that when you're doing more of this route-based as opposed to HTTP web app inspection with the DLP and the malware inspection, it's more like just a routing connection, except that it's not exposing the entire network, right? It's only the ports and protocols that you have permitted.
So VoIP will work as well if I have a VoIP phone and I want to call Dimitri?
Yes.
You can connect your soft phone either on your computer, or you can take your office phone and configure it to use somehow a BitGlass cloud to connect to the office. Right,
not necessarily agentlessly. So it depends on how the connection is established. If it's like a thick client application, then you'd be using our BitGlass Smart Edge agent to do that versus more of a web-based connectivity. So it depends on the use case that you're talking about, but yes, both are possible.
Password reset and patching. Any with Active Directory, for example, same idea?
Yeah, same idea. Typically, what we see people doing there's I think two approaches to that. In the more recent versions of Active Directory, ADFS in particular, they have things like self-service password reset type capabilities, and sometimes people don't want to expose those, obviously, to the internet. Sometimes they do, and so if they don't, what you'd be doing is you'd be going to that page that's serving up that self-service password reset and doing that, as opposed to accessing from the internet, which is typically blocked, right? So those are possible as well. How your solution would work on a slow network, or example, if I'm roaming between networks, right? Okay, so network roaming, I think we covered a little bit a second ago when I was talking about the session being established and being in remaining, right? So if I leave and I go to a different place, it's still established and still going on. But one of the key things there is availability, right? And are those pops that you were asking about kind of at the beginning of the podcast. And so if we look at this particular slide over here, this actually outlines the BitGlass service. And so what we actually have is over 200 points of presence. Again, I said we were built on a public cloud infrastructure, which allows us to do this. Actually, I think we did a press release recently around 280 at this point. And what's going on is we have a mix of things that we call core and edge data centers for connectivity with uptime of actually 99.99%, which is unheard of and actually externally published as well. But what's going on is we're deployed globally. We have these core data centers and we have these local edge data centers and CDNs and whatnot, and the Smart Edge endpoint agent that we were talking about for providing that ZTNA access or that secure gateway control or CASB functionalities. But what we do see is that in places where the connectivity is actually poor, for example, sometimes Latin America, sometimes we can actually speed up the connectivity. And that sounds a little bit counterintuitive, but it's because we're running on this global backbone that is really fast. And so while you don't have to hop between a whole bunch of different local ISPs, you get onto this fast network automatically, and it connects you globally to wherever you need access to, both internally and externally to like a SaaS app, for example.
When you mention that you always connected, do you use any particular protocols, SSL, IPsec, or
it's using SSL? So we're not using IPsec tunnels. It's SSL.
From a reporting perspective and user behavior, what's popular? What people want to see from remote access? Or maybe you can understand that Evgeny logged in from Toronto today, but tomorrow from Singapore, and that his behavior changed.
that's a core functionality to the solution in general. So if you think about the, I guess we talked about this maybe in the last podcast, but all the policies that are associated with UEBA, you can detect things like new devices you've never seen before. You can detect things like suspicious user location, where maybe someone's trying to hack them, and that's happening in North Korea, and then you're actually located in London and whatnot. So we can detect that and block that. Or typical things are requiring step-up two-factor authentication. Because if you block the access, then at that point you're basically DDoS user, right? You don't want to do that to anyone really, or the high executives or whatnot. But what we were doing is looking at the activities of those individuals, even post login as well. So maybe someone starts to download a whole bunch of sensitive information that may trigger and put them in a risky group that's going to then do inspection and more stringent access controls, maybe cut them off from all the ZTNA applications, for example. So you can do all these types of things. There's basically log analysis, there's reporting. We have integration with different types of SIMs. We have apps that are in the marketplace for Splunk and QRadar, for example. And so there's a lot of different types of stuff there. But one thing, going back to that kind of network routing approach that you see from some of the vendors with ZTNA versus this adaptive access control, is what Gartner calls it, is that you need to stay connected and stay in the path of the traffic even after the login, right? So you can see what the person's doing, and then when they do that sensitive thing, take an action like cut off that access. And so we do that persistently even after the login versus just routing traffic.
I don't have any questions here anymore. Mike, any other topics you want to discuss?
I mean, I think the biggest one that's been happening more frequently over the course, actually highly accelerated over the last year, is the convergence. And so what we've seen in the last 2 years is basically the convergence of CASB and Secure Web Gateway. What we're seeing now is the convergence of Zero Trust Network Access, what we've been talking about, this remote access, the entire podcast, as well as remote browser isolation. And so solutions that are these SASE solutions, we're one that focuses on the whole cloud security side of things. So all those have converged into one platform. So it's not a point solution, and you're really actually saving money from an ROI perspective. So what you really want is consistent policies and management. You know, if you buy all these point individual solutions, it starts to become really confusing and difficult to implement consistent security. So it's not just an ease of use perspective, but it's also a consolidation perspective for money-saving opportunities, as opposed to separately purchasing different solutions and trying to cobble them together, kind of like that spaghetti in that first slide that I was showing.
What would you say, a couple of main use cases, why people move from traditional VPN, remote access VPN, to your solution?
Well, there's the biggest one is that with the pandemic and whatnot, and people working from home, which is probably here to stay even after the pandemic, all the VPN concentrators that people had that were normally, you know, maybe 5% of workers were working at their houses. Now it became 100%, right? And maybe in the future, it's going to be 70% stay at home all the time. They were just swamped and overrun and not able to actually service the load. So what we're seeing here is an ability to provide this scalable security and access from the cloud. So that's kind of the biggest change that has happened more recently.
Last question. If you can tell us a story about something that really didn't work for you during implementation for BitGlass and you guys were able to solve it, or some anecdote about it.
So, I mean, some of the stuff that we're seeing is kind of interesting. We've seen some use cases where people have even legacy operating systems that they might need access from. So we have actually some large customers that, for example, are running Windows 7. And since they have so many laptops running Windows 7, it's hard to get off of Windows 7, even though the end of support was a little while ago, right? And so our Smart Edge agent can support Windows 7 and still provide that connectivity and whatnot, both be it for things like secure web gateway controls and threat blocking, which is obviously a huge thing when you're running an operating system that's unsupported, but then also for these ZTNA type use cases. And so when we went into that opportunity initially, they were pretty surprised that we had support for that and that we could provide these connectivity options when not many others were. And some of the existing vendors were actually pushing them off of using their service because they didn't want to support it. Yet, we have been and have with our normal agents for a long time. So we said, oh yeah, go ahead and try this out. And it seemed like a win-win for both of us. So we moved forward.
Thank you very much.
Thank you.
Please remember to subscribe to our podcast and join us for our next episode.